Good day to all of you. We have started studying DBMS, that is Database Management Systems. In that chapter 3, data modeling using the entity relationship, that is ER model. Our sincere acknowledgement and thanks to authors Ramesh L. Masri and Shamkat P. Nawate, authors of the textbook being Fundamentals of Database Systems. The content of whole discussion I have taken from this textbook. So in this first, we have to know what is entity, then entity types, entity sets, attributes and keys. The ER model means entity relationship model. It describes data as entities, relationships and attributes. So what is entity? Entity is a thing or object in the real world with an independent existence. For example, person, student, university, course. So these are the things which have their own existence. What is tangible entity? An entity with physical existence which we can touch and feel. Such kind of entities are called as tangible entity. For example, particular person, car, house, employee. These are the objects in the real world which we can touch and feel, which have got physical existence. Hence they are called as tangible entities. Intangible entities, on the other hand, entities which we cannot touch and feel, which do not have physical existence but have conceptual existence. Such kind of entities are called as intangible entities. For example, company, job, university course. So these we cannot touch and feel. They do not have physical existence but they have conceptual existence. So such objects from real world, they are called as intangible entities. Attributes. The properties of an entity are called its attributes. For example, employee entity, if we take, it can be described by employee's name, age, address, salary, job. So employee's name, age, address, salary and job are called as attributes of entity employee. Okay. Next we shall see to an example relation or table. Here the relation name is employee. This employee is having 10 attributes or properties and they become the 10 columns here. Namely F name, M minute, L name, SSN, B date, address, gender, salary, super SSN, DNO. So the number of columns in a relation is called as its degree. So there are 8 rows in this relation. So that is called as cardinality of the relation. So number of columns is called as degree of the relation. Number of rows is called as cardinality of the relation. So SSN attribute, that column name here, it is underlined. So it indicates that the attribute SSN is called as key attribute. That is, two employees cannot have same value for this key attribute. This is one row of data in the relation. That is also called as record or tuple. So there are 8 rows, means 8 records or 8 tuples. Each tuple will store details of one employee. Hence it is storing 8 employees details. Okay. Next, these are the different values stored for salary attribute for different employees. Suppose the value here, it is restricted to be stored from 20,000 to 1 lakh. Then this 20,000 to 1 lakh becomes the domain for this attribute, that is salary. These are some of the terms that we have seen in case of relation. That is, relation means table. It is systematic collection of data in the form of rows and columns. Row of data is called as record or tuple. The number of columns or attributes which are stored in the form of column names, that becomes degree of the relation. The number of rows or tuples which are also called as records, that is called as cardinality of relation. The attribute which has unique value for different entities, that is called as key attribute. Then range of values we can give for an attribute, that is called as domain. So these are some of the terms that we have come to know in case of relation. Okay. Apart from these terms, there are two more terms, that is intension and extension. This set of column names which are attributes which indicate structure of entity, that is called as intention, and set of all the values for the attributes in the relation, that is called as extension. Okay. So that is what is some small discussion about relation. Here the figure is showing two entities, that is employee entity 1, that is E1, company entity 1, that is C1. The employee entity E1 has four attributes, that is name, address, age and home phone. So name, address, age and home phone. These are the attributes. Their values are John Smith, then address value, age value and home phone value. Here values are shown. Similarly, for company entity C1 there are three attributes, name, headquarters and president. So name, headquarters and president, and their values are Sunco Oil, Houston, John Smith respectively. So the values are shown here. Okay. So this figure is showing two entities, employee E1 and company C1 and their attributes. Next we shall discuss what are the different types of attributes. So first let us recall what is attribute. Attribute is the property of an entity. Okay, there are different types of attributes, namely simple attribute, composite attribute, single valued attribute, multi-valued attribute, stored attribute and derived attribute. Okay, then we shall study what is the concept of null value for an attribute. Then we'll have a discussion on simple versus composite, single valued versus multi-valued, stored versus derived. First we'll define these attribute types and then we'll illustrate them using examples. Then we discuss the concept of null value for an attribute. Okay. First let us know what is simple attribute and composite attribute, and we shall have some discussion on simple versus composite attributes. Simple attribute is also called as atomic attribute. The attributes which are not divisible are called as simple or atomic attributes. For example, roll number, age, gender, these cannot be further divided, so they are called as simple attributes. Composite attribute. Attributes which can be further divided are called as composite attribute. For example, address attribute, which is shown here. It can be further divided as street address, city, state and zip. Street address can be further divided as number, street, apartment, number. So such an attribute which can be further divided, that is called as composite attribute. If composite attribute is referenced only as a whole, then whole address can be designated as simple attribute. Next we shall see what is meant by single valued attributes and multi-valued attributes. Single valued attributes. The attributes which have single value for a particular entity, they are called as single valued attribute. For example, age is a single valued attribute of a person. Multi-valued attribute. Attributes which have multiple values for a particular entity are called as multi-valued attributes. Suppose if you take for example colors, this can have any value. So colors of a car, so it can be white, black, blue. Hence colors attribute is a multi-valued attribute which can have multiple values. College degree. This attribute of a person, that can also have multi-values, because depending on what all qualifications a person has got, college degree attribute of a person can have multiple values. So multivalued attribute may have lower and upper bounds to constrain the number of values allowed for each individual entity. For example, colors attribute of a car may be restricted to have one or two values if we assume that a car can have two colors at the most. So this depends on the application. Okay. So next let us know what is stored attribute and derived attribute. So the age attribute is called as derived attribute. Birth date attribute is called as stored attribute. If a person entity, the value of age can be determined from today's date and the value of person's birth date. Means in a table if birth date is stored, from that using today's date we can calculate the age of that person. So we can get the value of age attribute. Hence age attribute is called as derived attribute. Its value can be derived from some other stored attribute, that is birth date here. In some cases, two or more attribute values are related. For example, age and birth date attributes of a person are related. Some attribute values can be derived from related entities. For example, an attribute number of employees of a department can be derived by counting the number of employees related to working for that department. Okay. So that is all about stored versus derived attribute. Next, what is meant by null values? When a particular entity doesn't have applicable value for an attribute, then null value is stored. Case 1. Not applicable. For example, apartment number attribute of an address applies only to addresses that are in apartment buildings, not to other types of residences such as single family homes. Similarly, college degree attribute applies only to people with college degrees. For such situations, a special value called null is created. An address of a single family home would have null for its apartment number attribute. A person with no college degree would have null for college degrees. Next, second case in case of null. So first case was null value is used for an attribute when it is not applicable. College degrees for uneducated person. Then if anybody is not living in apartment but apartment number attribute value is to be filled, then null value would be filled. So that was case 1. Now in case 2, not known. So null can also be used if we do not know the value of an attribute for a particular entity. So in this there are two cases. The first case, when it is known that the attribute value exists but it is missing. For instance, if height attribute of a person is listed null, means height of the person do exist but it is not now, then the value for height attribute is entered as null. So this is the first case of not known. The second case in not known is whether the attribute value exists or no, that we don't know. For example, if the home phone, for this attribute if you have to fill the value in the table, then whether that person is having home phone, yes or no, we don't know. So in that case, the attribute home phone, its value is filled as null. So this is case 2 of null. The case 1 was not applicable. Case 2 is not known. In not known, there are two cases. The value exists but not known at present, means it is missing. And the second one, the value whether it exists or no, that only is not known. So in such case, value for an attribute is filled as null. So this is all about second case. So these two cases, that is case 1 not applicable and case 2 not known. In that value exists but it is missing, Whether value exists, yes or no, that we don't know. So these are the cases in which the value of an attribute is filled as null. Okay. Next, let us know about complex attributes. Complex attributes are found by nesting composite and multivalued attributes. For example, if a person can have more than one residence and each residence can have single address and multiple phones, an attribute taken for this is address underscore phone for a person. So it can be specified as in the figure that we are going to see next. We can represent arbitrary nesting by grouping components of a composite attribute between parentheses and separating the components with comma, and by displaying multivalued attributes within flower brackets. Such attributes are called complex attributes. So which is written here and that is drawn clearly in the next figure. Figure shows complex attribute address phone. So that is this attribute. This complex attribute address phone is formed by nesting of multivalued and composite attributes. So this address phone is multivalued and composite attribute because it can be further divided into two composite attributes. This is multivalued composite attribute phone and single valued composite attribute address. This multivalued composite attribute phone is further divided into two simple attributes, area code and phone number, each separated by comma. Okay, this single valued composite attribute address is further divided into street address, city, state and zip attributes which are separated by comma. Okay. So this kind of formation is required because if a person can have more than one residence, so this is multi-valued attribute, that is address phone. Then each residence can have single address. So address is single valued composite attribute and multiple phones and multi-valued composite attribute, that is phone. That is how one complex attribute is found by nesting of multi-valued attribute and composite attributes. That is what is all about complex attributes which are found by nesting composite and multi-valued attributes. Okay. Next we shall study about entity types, entity sets, keys and value sets. Here employee is the entity type. E1, E2, E3 are the member entities which belong to employee entity type because all the three entities have the same attributes, that is name, age and salary. Okay. John Smith 55, 80K are the values for name, age and salary attributes of employee entity E1. Similarly, Fred Brown 40 and 30K are the values for name, age and salary attributes of employee entity E2. Judy Clark 25 and 20K are the values for name, age and salary attributes of employee entity E3. E1, E2, E3 are the member entities of employee entity type because all the three have same attributes, that is name, age and salary. This attribute set name, age, salary which indicates the employee entity type structure, that is called as intension. Employee entities E1, E2, E3 together they are called as entity set. The value sets at any instant of time which are stored in database, that is called as extension. Similarly, we have company entity type. Its attributes are name, headquarters and president. This set of attributes which represents the company entity type structure that is called as intension. C1 and C2 are company entities which belong to company entity type because they have the same attributes as company entity type, that is name, headquarters and president. Sunco Oil, Houston and John Smith are the values for name, headquarters and president attributes of company entity C1. Fast Computer, Dallas and Bob King are the values for name, headquarters and president attributes of company entity C2. Collection of company entities C1 and C2 together, it is called as company entity set. The value sets, these together which are stored in the company database, they are called as extension of company entity type. And that is all about entity types, entity sets and value sets. About keys or key attributes we shall see next. Okay. Next, key attributes of an entity type. An attribute which has unique value for an entity is called as key attribute for that entity. So its values can be used to identify each entity uniquely. Example, social security number for an employee, USN for a student. Okay. So some entities will be having more than one key attribute. So key attribute has its name underlined inside the oval. So this is an attribute, but these are key attributes. So they are underlined within oval. So attribute is written within oval, but key attributes are written with underline within oval. For example, car entity type with two attributes, that is registration and vehicle ID, that is shown in the figure here. So we are showing car entity and their attributes in the form of a diagram, and this is called as ER diagram notation. ER diagram means entity relationship diagram. So car entity type is represented with rectangle, attributes are represented with ovals, key attributes are shown with underline within oval. So this ER diagram we shall see later with what all symbols they can be represented. Okay. So if you observe this ER diagram notation of car entity type, several ovals we can see. So they are all attributes, but different attributes it is showing, whatever so far we discussed under the different types of attributes. So year is one attribute, model is one attribute, make is one attribute. These are simple attribute. So within double oval here it is shown one inside the other. So that indicates color is multi-valued attribute. So it is having multiple values for that attribute. Then vehicle ID is the key attribute because it is underlined here. Each vehicle will be having their own IDs, that is unique values. Hence it is the key attribute. One more key attribute is there, that is registration number. So that is also written within oval and underlined. This example is having two key attributes. So this is simple key attribute, but this is composite key attribute because registration number can be further divided as state code and number part. Okay. And that which is shown in the rectangle type, that indicates car entity type. So the remaining are all attributes, but different kinds of attributes are shown in this example. Okay. So this figure shows car entity set. Entity set means collection of entities. So this is the collection of car entities. So car 1 entity, car 2 entity, car 3 entity. Collection of car entities together, it is called as car entity set. So next, if you consider car 1 entity, So these are the values of attributes for the car entity 1. So these two values together form the value for composite attribute, that is registration ID. So registration ID composite attribute can be further divided into state code and number. So this is the value for state code of car 1 entity, and this is the value for number part of registration ID for car 1 entity. Okay, so this is the simple attribute, that is vehicle ID value, that is TK629. So this is a simple attribute car model value. So this is simple attribute car make value. So this is simple attribute year value. But this is a multivalued attribute colors values. So this model is available in two colors, that is red and black. Okay. So next car entity 2, if you consider, so this is composite attribute registration ID value having two parts. One is state code value, that is New York, and number value, that is ABC space 123. This is vehicle ID value WP9872. This is car model value, that is Nissan Maxima. This is car make value 4 door. This is car year value, that is 2005. This is multivalued attribute colors attribute value, that is blue. So this model is available only in one color. So to the max listed here is two colors. So lower bound and upper bound we can impose on the multivalued attribute values depending on the application. Here for car they have imposed two values. So minimum one value is present here, to the maximum two values are present here. Car 3 entity, if you take, this is composite attribute registration ID value, which has two parts, state attribute and number value is VSY720. This is vehicle ID value TD729. This is model attribute value Chrysler LeBaron. This is make value 4 door. This is year attribute value 2002. This is multivalued attribute colors white comma blue. So this model is available in two colors. So that is all about entity set of car with three kinds of attributes, that is simple attributes, composite attributes and multivalued attribute. Okay. So here vehicle ID, vehicle model, make, year are simple attributes. So registration ID is the composite attributes which is further divisible into two, one as state code, another as number. And colors attribute is multivalued attribute which can have one value or to the maximum two values. Okay. So this figure shows the value sets for the three car entities for different attributes. This figure shows ER diagram notation of car entity type. Vehicle ID, model, make, year are simple attributes. Among these simple attributes, vehicle ID is the key attribute also. Next, registration ID or registration number, it is a composite attribute which is further divided into state code part and number part. And color is the multivalued attribute which was having to the min one color and max two colors which were shown in the value set. Okay. And that's all about ER diagram notation of car entity type, and as an example we saw to its value set also. It's a very good example and a very unique example. Okay. Next we shall know what is meant by strong entity type. An entity which does have key attribute is called as strong entity type. Next, weak entity type. An entity which doesn't have key attribute is called as weak entity type. For example, employee, if you take, it is a strong entity type because it has key attribute social security number of employee. Next, dependent entity type, if you take, that is weak entity type because it is identified by employee whose dependent he or she is. So it doesn't have its own key attribute. Hence, dependent is called as weak entity type. Next, we shall know about relationship. So far, we have discussed about entities and attributes. So next, we shall discuss about relationship. Okay. So relationship is an association between entities. Then what is degree of relationship? The degree of a relationship is the number of participating entity types. There are different kinds of relationship types, that is binary relationship, ternary relationship and n-ary relationship. So first let us know what is meant by binary relationship. Binary relationship means it is the relationship which has the degree 2, means participating entities are 2. So here works for relationship, if we take in a company database, so participating entities are 2 here. One is employee and another is department entity type. Okay. If only two entities are participating in a relation, then it is called as binary relationship. So this figure is showing binary relationship works for that exists between employee and department entities. Okay. So another example for binary relationship is managers relationship. If you see two figure here, so this is the managers relationship, which is binary relationship because it is association between two entities. One is employee, another one is department. So employee entity E3 is participating in manager relationship instance R1 where he or she is managing the department D1. So that is what is indicated in the figure. So this figure is showing binary relationship managers that exist between employee and department. So here R1, R2, R3, these are called as relationship instances. In each relationship instance, two entities will be participating. That is what is called by binary relationship. Okay. Next we'll see what is meant by ternary relationship. So if degree of relationship is 3, then that is called as ternary relationship. Means if participating entities are 3. Here the relationship name is supply. In this participating entities are 3. One is supplier, another is project and third one is part. Hence supply relationship is ternary relationship. So this figure is showing ternary relationship, that is supply. If more than 3 entities are participating, then that relationship will be called as N-ary and degree of that relationship will be N. Okay. That is all about relationship. That is what is relationship and what are the different types of relationship. Okay. So next we shall study about cardinality of relationship. Already we have heard to the term cardinality. That was cardinality of relation or table. So the number of rows in a table or relation is called as cardinality of relation. Now we have to know cardinality of relationship. So the definition is the relationship cardinality defines how many instances of one entity or how many entities of one entity type are related to instances of another entity. Means in a relationship, how many number of entities of one entity type are participating, that becomes cardinality of that entity in the relationship. So next we shall know what is the meaning of this. Okay. So the number of times an entity of an entity set participates in a relationship is called as cardinality. So there are different types of cardinality between entities as far as relationship is concerned. So they are one to one, one to many to one, many to many. So next we shall see what are these. So the first one is one to one. So in this type of cardinality mapping, an entity in A is connected to at most one entity in B, or we can say that a unit or item in B is connected to at the most one unit or item in A. So suppose if you take employee as A, so department as B, and the association between the two is manager's relationship. So this is relationship instance in which only one entity E3 is participating with another only one entity from B. Okay, that is D1. So here in a particular company, one employee manages one department. They serve one-to-one relationship. That is exactly what is shown in this figure about managers relationship. So managers relationship is one-to-one type. One employee manages one department in a company. So such kind of relationship is shown as one-to-one relationship. So that can be observed in the figure here. So next we shall discuss on one-to-many relationship. Here relationship controls, if you take, which exists between department and project entities in a company database. So it is one-to-many relationship type because one department can control many projects. So one department entity, that E1, so it is controlling here project 1 and project 2. That is what is shown in the figure here. So this R1 is relationship instance 1 in which E1 department is controlling project 1. R2 is relationship instance 2 in which the same E1 department is controlling E2 project. Okay. So that shows one department can control many projects. So controls is one to many relationship type. So that is what is shown in the figure here. In this type of cardinality mapping, an entity in A, so that is A is department here, is associated with any number of entities in B. So project is B here. So one entity in A is associated with two projects in B as far as controls relationship is concerned here. Okay. So the next one is many to many relationship type. So in this cardinality mapping, an entity in A is associated with any number of entities in B. So employee entity if you take as A, project entity as B. So one entity in A is associated with P1 here. But E2 entity if you take, it is associated with P1 and P4. So one is associated with many in the 2 here. Similarly, on other side, if you take P1 project, it is done by E1 entity and done by E2 entity. So here one is associated with many here. Here one is associated with many here. Finally, we have many to many relationship between the two entities, that is employee and project. And the name of relationship is works on. So this figure is showing many to many works on relationship. Okay. Next we shall study what is meant by role names and recursive relationships. First we shall see about role names. So in a relationship, entities do participate. Each entity type that participates in a relationship type plays a particular role in the relationship. Okay, suppose if you consider this figure, works for relationship is shown here. The participating entities are employee and department. Employee entity type plays the role of employee or worker in the relationship works for. Department entity plays the role of department or employer in the relationship works for. That is what is shown in this figure. One relationship, two participating entities. One is playing the role of employee or worker. Another is playing the role of department or employer. So in this figure we can see the participating entities which do participate in a relationship and what role they play. Okay. Next, we shall study what is meant by recursive relationship or self-referencing relationship. So here employee entity is shown and supervision relationship is shown. So employee entity is participating in the relationship and it is referencing back the same employee entity type. Once it is playing the role of supervisor and another time it is playing the role of supervisee. Any relationship in which the same entity type participates twice, plays two different roles, that kind of relationship is called as recursive relationship or self-referencing relationship. The same can be seen in this figure. So in this figure, a recursive relationship supervision between employee in the supervisor role, that is 1, and employee in the subordinate role in 2, it is shown. So wherever 1 is there, it shows supervisor role. Wherever 2 is there, it shows supervisory role. So this figure shows that entity E1 is connected to R2 relationship instance through line 1, means E1 acts as the supervisor. To the same relationship instance, E2 entity is connected through line 2, means E2 acts as supervisee. Hence, E1 supervises E2. Similarly, we can verify that E1 supervises E3, E4 supervises E6 and E7, E5 supervises E1 and E4. So here line 1 indicates supervisor role, 2 indicates supervisee role. So to connect employee entity with the supervision relationship, 2 lines are required. Okay. So when same entity type participates twice in a relationship, that relationship is called as recursive relationship. Here employee entity type is playing two roles in the relationship supervision, once as supervisor and another time as supervisee. So such kind of relationship, that is called as recursive relationship, and here the name of relationship is supervision and participating entity is employee and it is playing two roles. Okay. That is what is all about recursive relationship. With that, we shall move on to next topic. Next, we shall study about ER diagram or entity relationship diagram, which is abbreviated as ERD. So in diagrammatic form, it represents the different entities, their attributes and relationships. ER diagram or entity relationship diagram, it is visual representation of structure of database. They represent ER model in a database, making them easy to convert into relations or tables. The components of ER diagram are entities, attributes, and relationships among entities in a database system. So ER model or ER diagram, visual representation of ER model. that has entities. In that it may have strong entity and weak entity. So this ER diagram will be having attribute. In that different types of attributes will be represented: key attribute, composite, multivalued and derived attribute. And that will be showing the relationship between one entity with the another entity. So the relationship between two entities, they are termed as one to one, one to many, many to one and many to many. So these are the components of ER diagram. Okay. So the different symbol used in ER diagram are: this rectangle indicates strong entity, one rectangle within another rectangle that represents weak entity. Then this oval shape indicates attribute. In oval shape, any attribute mentioned, if it is underlined, that indicates key attribute. So this oval shape within which we have dashed underline for an attribute, that attribute is called as partial key. It is key attribute of weak entity. Okay. So this dashed oval indicates derived attribute. So if double oval one inside the other, that attribute indicates multivalued attribute. So this indicates composite attribute. Here we write composite attribute name, which can be further divided into several attributes. Okay. Then this diamond shape indicates strong relationship. This double diamond shape indicates weak relationship. Two lines indicate total participation. One line indicates partial participation. So these are the symbols that are used in drawing ER diagram. Okay. Now the relationships, if you consider R is the relationship here, which is shown with the diamond symbol, and that is associating E1 entity and E2 entity. So E2 is totally participating in the relationship R. E1 is partially participating in the relationship R. And as far as cardinality is considered, if you see to this figure, in the relationship R, E1 and E2 are participating. So one entity E1 is participating with n entities from E2. This is 1:n cardinality ratio. Okay. One department can control several projects. So here one department, here this is controls relationship, can control several projects. So n number of projects. So in the relationship controls, the cardinality ratio between participating entities E1 and E2 is 1:n. So another is written, that notation, min-max notation. So this is relationship here, entity here. So structural constraint will be shown. Minimum number and maximum number on participation of E in relationship R. How many entities belonging to entity set E are participating in the relationship R? How many minimum it can participate? How many maximum it can participate? So that is min-max notation. Okay. So these are as far as participation of entities in a relationship is considered. Next we shall take an example database application, that is company database. So company database is organized into several departments. Each department is having unique name, unique number, and a particular employee who manages the department. We keep track of start date when that employee began managing the department. A department has several locations. A department controls number of projects, each of which has a unique name, unique number, and single location. The database will store each employee's name, social security number, address, salary, gender, and birth date. An employee is assigned to one department but may work on several projects which are not necessarily controlled by same department. It is required to keep track of current number of hours per week that an employee works on each project, as well as direct supervisor of each employee who is another employee. The database will keep track of dependents of each employee for insurance purposes, including each dependent's first name, gender, birth date, and relationship to the employee. So this is a description of company database. This sample we are considering as to learn how to draw ER diagram completely for the given sample database application, that is company database. Already we have seen to the symbols that are used in the ER diagram. Using those, how to draw the complete ER diagram for this sample company database, that we shall see next. So for the company database, in the initial conceptual design, first we have to define entity types based on requirements. Secondly, we define attributes for entity type. Next, we identify relationships between the entities. So whatever description of company database just now we took, so according to that, in a company employee is there, and all these indicate the attributes of employee. So the employee is having social security number, and it is the key attribute because no two employee can have same social security number. They will have unique values. So for an employee, for which department he or she is working, what is his or her birth date, that employee's address, who is the supervisor, what is employee's salary, then gender. Then if you take employee's name, it is a composite attribute. It is further divided as first name, middle initial, and last name. And one more works on, which is a composite attribute here. It can be further divided as employee works on which project and for how many hours. So this is a representation of employee entity with attributes. Next, similarly, department entity with attributes. So department, who is the manager, then manager when he started working as manager. Here name attribute, that is department name, it is underlined because it is the key attribute. That means no two departments in a company can have same name. They will have unique values. Hence name is the key attribute. Similarly, department is given the number, unique number. No two departments can have same number. Hence number is also the key attribute. So locations, if you take double ovals are written here, one inside the other. So location attribute is multivalued. One department can run in different locations. That is what is the meaning. So this is as per the description of company database taken. So next, project entity. Its attributes are location of project, project name, which is key attribute because two projects cannot have same name, project number. It is also key attribute because no two projects can have same number. And this attribute indicates controlling department. Okay. So this shows project entity along with its attributes. The next entity is dependent. Dependent entity attributes are, so employee means dependent is dependent of which employee. Then dependent name, dependent birth date, dependent relationship with the employee, dependent gender. So this diagram shows dependent entity along with its attributes. So this is the preliminary design of entity types for the company database. Okay. Here knotted relationships are shown. When this diagram is developed further, then relationships will be shown as per the company database description. Now this is the complete ER diagram of company database, in which we have entities, their attributes, and the relationships between the entities. So employee entity, its attributes, department entity, its attributes, project entity, its attributes, dependent entity, its attributes. Apart from this, we'll have to see the representation of relationship. The relationships in this diagram are works for relationship, manages relationship, works on relationship, controls relationship, dependence of relationship, and supervision relationship. All the relationships are shown in diamond shape, but dependence of relationship is shown in double diamond shape, one inside the other, because this is a weak relationship. Weak relationship is the relationship that exists between one strong entity and another one is which is weak entity. Strong entity is shown in single rectangle. Weak entity will be shown in double rectangle, one inside the other. Okay. Next we shall see to cardinality ratio of participation of participating entities in a relationship. For example, if you take for works for relationship, there the cardinality ratio is n:1, means the participating entities are employee and department in the relationship works for. The cardinality ratio of their participation is n:1, means n employees can work for one department. That is, any number of employees can work for one department. Okay. Next, cardinality ratio of participation in the relationship manages by entities employee and department is 1:1. That is, one employee can manage one department. So that is the cardinality ratio of participation is 1:1 here. One employee can manage one department. Okay. Next, works on relationship. If you take here M is written and here N is written. The participating entities are employee and project. So M indicates M employees can work for N number of projects. So the cardinality ratio of participation is M:N. That is, M number of employees can work for N number of projects. Means any number of employees can work for any number of projects. Okay. Next, considering controls relationship, participating entities are department and project. Here 1 is written, here N is written. One department can control N number of projects. So one department can control any number of projects. That is what is the meaning of this cardinality ratio of participation. Okay. If you take up dependence of relationship, it is between employee entity and dependent entity. 1:N is the cardinality ratio of participation here. So one employee can have N number of dependents, means one employee can have any number of dependents. That is what is the meaning of this cardinality ratio of participation. Relationship here is supervision. It is a recursive relationship because so when an entity references back the same entity in a relationship, then that relationship is called as recursive relationship. Here 1 is written, here N is written. So cardinality ratio of participation is 1:N. That is, one employee can supervise N number of employees. That is, one employee can supervise any number of employees. That is what is the meaning of this cardinality ratio of participation. Regarding cardinality ratio of participation of the participating entities in a relationship. Next, we shall see what is meant by partial participation and total participation of the entities in a relationship. Partial participation is represented by single line. Total participation is represented by double line. If all the entities in an entity type do participate in a relationship, then that is called as total participation. If only few entities belonging to an entity type participate in a relationship, then it is called as partial participation. So here works for relationship, if you take, the entities which are participating are employee and department. So employee is connected with double line to works for relationship. That means employee entity totally participates in works for relationship. That is, all the employees do participate in works for relationship, hence it is total participation. All the departments are worked upon by employees and hence department entity totally participates in the relationship works for. Similarly, employee entity partially participates in the relationship manages because all the employees are not managers. Only few employees do management, hence it is partial participation. Department entity totally participates in manages relationship because all the departments are managed by employee. Next, department entity partially participates controls relationship because all the departments do not control the project. All the projects are controlled by department and hence project entity totally participates in the relationship controls. Next, if you consider works on relationship, the participating entities are employee and project. Here double line is shown, that is all the employee work on project. That is total participation of the employee entity. Here double line is shown on project side, that is all the projects are worked on by employees. Hence it is a total participation by project entity. Next, dependence of relationship, if you take, employee entity partially participates in dependence of relationship because all the employees may not have dependents, but dependent entity totally participates in the relationship dependence of because all the dependents have are the dependents of any one employee. So as far as supervision relationship is considered, on supervisor role, partial participation is shown because employee entity partially participates in supervisor role in the relationship supervision because all the employees do not do supervisor role. Few employees work as just employees, they do not supervise anybody. That is why it is partial participation of employee entity in supervisor role. In supervisory role also, all the employees are not supervised by. So hence the participation of employee in the role supervisory of the relationship supervision is partial participation. Okay. That completes the discussion on partial participation and total participation of an entity in a relationship. Okay. Here in case of dependent entity, so name attribute is shown, that is with dashed underline. That indicates that it is the key attribute of weak entity. Okay. Next, this start date attribute on manages relationship shows when an employee started managing the department that need to be recorded in the database. So this dashed oval shows that number of employees attribute is derived attribute. So it can be derived from the information that how many employees are present in the working for list of department. Okay. So that is what is regarding derived attribute. So hours attribute is shown on works on relationship here. So it shows the necessity of recording an employee works on a particular project for how many years, because one employee can work on several projects, but on each project for how many hours he or she works is very important. That needs to be recorded, and hence hours attribute is shown here. Okay, so that is what is the complete ER diagram of company database, and we have learnt how to draw the whole of the ER diagram for company database. This figure shows ER diagram, that is entity relationship diagram of company database with structural constraints specified using min-max notation and role names. So what is meant by structural constraints? Structural constraints in database management system means cardinality ratios and participation constraints or rules together are called structural constraints. This is specified using a pair of number, that is min and max. So min max pair of numbers specifies minimum and maximum number of times one entity can participate in a relationship with another entity. Okay. This figure shows ER diagram for the company schema with structural constraints specified using min-max notation and role names. So first let us know what is meant by min-max notation. Min-max is the pair of numbers that is written on the line joining entity and relationship. Here min-max pair 1, 1 is written on the line joining employee entity with works for relationship. So minimum 1 indicates that employee can work for department to the minimum 1 department to the maximum 1 department only. This side min-max pair 4, n is written on the line joining department entity with the same relationship works for. So that is department can be worked upon by the employee to the minimum 4 employees to the maximum n number of employees means any number of employees. That is what is the meaning. So here 0, 1 min max pair is written on the line joining the employee entity with manages relationship. This minimum number 0 indicates that employee can manage 0 number of departments, means he is not manager at all, he is just an employee. To the maximum he can manage 1 department if he is a manager. The other side 1, 1 is written on the line joining department entity with same manages relationship. So this minimum 1 indicates department to the minimum can be managed by 1 employee, to the maximum it can be managed by 1 employee only. This 0, n is written on the line joining department entity with controls relationship. This minimum number 0 indicates that the department to the minimum can control 0 number of projects, means it is not doing any controlling of projects work, it is doing other work. If at all, if it is controlling, it may control n number of projects, that is any number of projects. So the other side 1, 1 is written on the line joining project entity with the same relationship, that is controls. This minimum number 1 indicates the project can be controlled by to the minimum 1 department to the maximum 1 department only. Next, considering this 1, n being written on the line joining employee entity with works on relationship. This minimum number 1 indicates that 1 employee can work for to the minimum 1 number of project to the maximum n number, that is any number of projects. The other side 1, n is written on the line joining project entity with the relationship, that is same works on relationship. So minimum number 1 indicates if at all if project is worked upon by employee, it is worked upon by 1 employee to the minimum n number of employees, that is any number of employees to the maximum. Next, if you consider this min-max pair 0, n being written on the line joining employee entity with dependence of relationship. This minimum number 0 indicates that an employee can have to the minimum 0 number of dependents. means he may not have any dependents. To the maximum he can have n number of dependents, means any number of dependents. The other side 1 comma 1 is written on the line joining dependent entity with same relationship, that is dependence of. This minimum number indicates that dependent is dependent of to the minimum one employee, to the maximum also one employee. Next we shall consider this 0 comma n, which is written on the line joining employee entity with supervision relationship. Here employee is playing the role of supervisor. This 0 minimum number indicates that employee is supervising 0 number of employees, means he is not supervisor at all. So to the minimum he can supervise 0 number of employees. To the maximum he can supervise n, means any number of employees. So either the employee is just employee, not a supervisor at all. That is what is this 0 means. If at all, if he is a supervisor, he may supervise any number of employees, that is n number, means any number of employees to the maximum. The other side 0 comma 1 is written on supervisory role side. It is written on the line joining employee entity with supervision relationship. So this minimum number 0 indicates that if an employee is being supervised, to the minimum he can be supervised by 0 number of employee, means he is not being supervised at all. If at all, if he is being supervised, to the maximum he is being supervised by one employee. That is what the meaning of this. That was ER diagram for company schema or database with structural constraints specified using min-max notation. Next we shall see to role names. Here in the supervision relationship, employee entity plays the role of supervisor and supervisee. Okay. Then in works for relationship, employee entity plays the role of employee and department entity plays the role of department. And in managers relationship, employee entity plays the role of manager, department entity plays the role of department being managed. In controls relationship, department plays the role of controlling department, project entity plays the role of controlled project. In works on relationship, employee entity plays the role of worker, project plays the role of project. In dependence of relationship, employee entity plays the role of employee, dependent entity plays the role of dependent. So these are the roles being played by different entities. They are shown in the ER diagram here. And that is all about ER diagram, that is entity relationship diagram for a company database with structural constraints specified using min-max notation and role names. And that completes the discussion on ER diagram of company database and data modeling using entity relationship, that is ER model. I hope you understood. Thank you.